friends, in this video we are going to study the classification of transducers. We will study that in how many categories and in how many ways the transducers can be classified with their examples. So let us start with our topic. The classification of transducers can be done in many ways. There are various categories or there are various criteria on the basis of which the transducers can be classified. So let us see that what are these criteria on the basis of which we can classify the transducers. So these are the various criteria on the basis of which we can classify the transducers. First is the method of energy conversion. We know that we can define transducer as a device which convert one form of energy into another form. So that the method which is used for the conversion of the energy, on the basis of that we can classify the transducers. Second classification or second criteria is the nature of the output signal, that whether the output signal is an electrical signal, a mechanical signal, an acoustic signal, okay, or an optical signal. So on the basis of the nature of output signal we can also classify the transducers. Then third criteria is according to the electrical principles involved. Okay, that which electrical principle is used for the conversion of energy, that on the basis of that also we can classify the transducers. Next is the electrical parameters used, that which electrical parameters are used, whether the resistance, conductor or an inductor, which electrical parameter is used in the transduction process. Okay. Next is the principle of operation, that on the basis of which principle the device, the transducer, is working. Okay, so on the basis of principle of operation also we can classify the transducers, and also on the basis of the applications of the transducers they can be classified. So there are many ways you can see that on, and there are many criteria on the basis of which we can classify the transducers. Now let us see that how we can classify the transducers into different categories. Okay. So first classification of transducers is based on the transduction principle used, and on the basis of this the transducers are divided into three categories: resistive, capacitive and inductive. This classification is based on the principle that in which form, that how the non-electrical quantity is converted into the resistance, capacitance and the inductance respectively. Okay, so if it is converted into a resistance, then it is a resistive transducer. If it is converted into capacitance, then it is a capacitive transducer, and if it is converted into inductance, then it is an inductive transducer. So first classification is based on the principle of transduction or the form of transduction used. Second classification of transducer. Okay, transducers can also be classified as the primary and the secondary transducers. Third classification and passive transducers. They are also classified as active and passive transducer depending upon that the source of energy, it is either generated by the transducer itself or it is given by some auxiliary source. Okay, that in what way the energy is supplied to the transducer. Okay, then next classification of transducer is analog and digital. Depending upon the type of output produced by the transducer, whether the output is an analog output or a digital output. Next classification of transducer is transducers and inverse transducers. Transducers can also be classified into the categories transducers and inverse transducers. Transducers are those devices which convert non-electrical quantity into electrical quantity, and inverse transducers are those transducers which convert electrical quantity into the non-electrical quantity. So these are the various categories in which the transducers are classified. Let us study these classification in brief. First, we will start with the first classification, which is on the basis of the transduction form used. As I have said that under this category, the transducers are classified as resistive, capacitive and the inductive transducer based upon the principle that whether the non-electrical quantity is converted into a resistance, a capacitance or an inductance. Now if we see the examples of these three types of transducers, so if examples are seen, then resistive transducer, its example is potentiometer, thermistor, resistance thermometer, and resistance strain gauge. These are some of the transducers which come under the category of resistive transducers. They are called resistive transducers because in these transducers, the resistance is varied due to the non-electrical quantity. Okay, due to the measurement, we are doing the measurements by measuring the change in the resistance. You can see that in the potentiometer, we are having a sliding contact. This sliding contact moves over the slider. So this is causing the displacement, and due to this displacement a voltage is produced. There is a change in the resistance of the potentiometer and a voltage is produced. So resistance variations in the resistance, they are measured, okay, they are caused due to a non-electrical quantity. Just like in the thermistor. In the thermistor, we are using the metals which are having the negative temperature coefficient. Means as the temperature increases, their resistance decreases. So we are measuring the changes in the temperature by measuring the changes in the resistance. So in you can see that in all these transducers, we are measuring the resistance. The change in the resistance is caused due to the changes in a non-electrical quantity, okay, due to the input quantity. So here how they convert the input quantity into the resistance, they are converting input quantity into the resistance. That is why they are called the resistive transducers. Now example of inductive transducers are. So these magnetic circuit transducer, reluctance pickup, differential transformer, these are the examples of inductive transducers. You can see that in the differential transformer, the differential voltage of the two secondary windings, okay, of the transformer is varied by positioning the magnetic core, okay. So we are changing the position of the magnetic core, due to which the inductance is being changing, and due to that inductance the differential voltage which is produced between the two windings, that is also changed, okay. So you can see that the input quantity, it is converted into the inductance, okay. Now coming to the capacitive transducers. Examples of capacitive transducers are variable capacitance pressure gauge, dielectric gauge. All these transducers, what they do, that in the variable capacitance pressure gauge, if we are changing the pressure, due to the changes in the pressure, the distance between the plates of the capacitor, they are changing, and if the distance is changed, then capacitance also changes. So in some way the pressure is converted into the change in the capacitance. So you can see that in these three types of transducer, the input quantity is converted into resistance, inductance and capacitance respectively. So on the basis of principle of transduction, transduction means the conversion of non-electrical to electrical quantity. So on the basis of principle which is used, this is the first classification of transducers. Second classification of the transducer is. Let us understand this classification of transducers with the help of an example. We are taking an example in which we are using the two transducers. One transducer is the Bourdon tube and another transducer is the LVDT, which is the linear variable differential transformer. Now you can see that in the LVDT we are having two windings. One is the primary winding and second is the secondary winding. Now primary winding is only one. There are two secondary windings in the LVDT, and in between these two windings a iron core is present. Okay, so we know that when the core is completely in between, complete core is there between the two windings, then maximum magnetic force will be generated, and due to that the output voltage generated in the LVDT will be maximum. Now as this core, it is moving upwards, less amount of core is present between the secondary and the primary windings, so less output voltage will be generated. So depending upon the length of the core which is inserted between the two windings, the output voltage, its magnitude changes. Okay, now this core is connected with the free end of the Bourdon tube. Okay, so as this Bourdon tube moves, the length of the cord which is inserted between the windings, it is also changing. Okay, now here in the Bourdon tube, this Bourdon tube works on the principle that when the pressure is given to it, the Bourdon tube, it displaces. Okay, so pressure is converted into the displacement. So due to the pressure which is coming into this Bourdon tube, the shape of this Bourdon tube changes. Its free end, it is going to move. Okay, so due to the movement of this free end, the movement of the core will occur. Okay, so as this free end moves, this core is also going to be either inserted inwards or it will come out of the space between the windings. Okay, so here you can see that pressure is first converted into displacement, and then displacement is converted into the output voltage. Okay, so in this way the conversion from a non-electrical quantity into an electrical quantity, it occurs in two stages. First stage is conversion of pressure into displacement, and then the displacement is converted into the output voltage. So first stage is called the primary transducer, that is the Bourdon tube, and the second stage is called the LVDT, which is called the secondary transducers. So wherever we are using the combination of two transducers in a measurement system, and where the conversion of the electrical to non-electrical quantity, it comes in two stages. We are having one as the primary transducer and other as the secondary transducer. So here we can say that the Bourdon tube, it senses the pressure and converted into displacement. Whereas the LVDT, it produces an output voltage which is proportional to the movement of the core. So here you can see that this transduction, that is the conversion of non-electrical to electrical quantity, it is in two stages. First stage, pressure is converted into displacement, and in the second stage, displacement is converted into voltage. So Bourdon tube is acting as the primary transducer and LVDT is acting as the secondary transducer. Okay. Now another example of the primary and secondary transducer is the combination of load cell and strain gauge. In this combination, the load cell, it acts as the primary transducer and strain gauge act as the secondary transducer. So what the load cell does, it converts the force into converts the mechanical displacement into the change of resistance. So load cell is acting as the primary transducer and strain gauge is acting as the secondary transducer. Now in most of the measurement systems there are two stages. One is the primary detector transducer stage, which is basically always a mechanical device. You can see that in the first example we were having the Borden tube as the primary transducer, and in second example we are having load cell as primary transducer. So both these are the mechanical devices. So in most of the measurement system we will have the primary detector transducer stage, which is a mechanical device, and the secondary transducer stage, which is an electrical device. So mechanical device is going to convert a mechanical quantity into an intermediate signal, and that intermediate signal is converted into an electrical signal by the secondary transducer. So this is how the transducers are classified into the categories primary and secondary transducers. The passive transducers, they derive the power required for the transduction from an auxiliary power source. We know that in the transducer, the conversion is taking place, and this process of conversion is called the transduction. So for this transduction process, the transducer, they will require some energy, some power will be required. So how this power is available to the transducer, on the basis of that, they are classified into passive and active transducers. In the passive transducer, the energy or the power which is required for the transduction, it is provided from an auxiliary power source, means from an external power source that energy will be supplied. That is why they are known as the externally powered transducers. Whereas the active transducers, whereas the active transducer, they do not require any auxiliary source. They will derive the power required for the transduction from the physical quantity or the input quantity which is being measured, and they develop their own voltage or the current output. That is why they are known as the self-generating type of transducers. So this is how the transducers are classified into the categories passive and active transducers depending upon the power source which is applied to them, whether this power source is external or whether it is self generated power source. Okay. Now, if we see the examples of passive and the active transducers, example of passive transducer is potentiometer. If we see the diagram for a potentiometer, that how a potentiometer works. So in a potentiometer, we are having a sliding contact which is moving over this resistance. The total length of this resistance is L and resistance is RT, and across this resistance the input voltage EI has been applied. Now the movement of this wiper on this slider, okay, or this sliding contact over this resistance, that is, this displacement is called the Xi, and the output voltage produced by the potentiometer is E naught. Now, if we see the value of this output voltage E naught, it will be Xi by L EI. Okay, means that the output voltage is equal to the ratio of this Xi by this length, means the value or the displacement of this wiper on this slider. Okay, so Xi by L, and this the input voltage. So we can say that Xi, that is this displacement, is equal to E naught by EI into L. Now here in this potentiometer, the energy which is required for the conversion of the displacement into the output voltage, that is provided by the there is an external source we are using, which is this input voltage source. Okay, so this is how, because we are using an external power source for this process of conversion, it is called a passive transducers. Now if we talk about the example of active transducer, piezoelectric crystal, it works on the principle that when force is applied over it, over this crystal, it is going to produce an output voltage, and inverse of this is also there, that when a voltage is applied to it, then acceleration is produced in the crystal. So piezoelectric crystal, if we draw the diagram for it, so in this we are having a crystal placed over it, and this crystal is placed over a base, and on this crystal we are having a mass. Now to the base we are applying the acceleration, that is, acceleration is going to produce a force due to this mass. Okay, and due to this force which is developed by the mass, an output voltage is generated, and this output voltage is generated, you can see that no input, no external power source is being used in it, and so this output voltage is generated by the device itself, by the transducer itself. So it is called an active transducer. Okay, whereas in this passive transducer we are using an input voltage source, so that is doing the conversion, whereas here the conversion, it is the power source is the input quantity itself, that is the acceleration itself. So piezoelectric crystal, it is a type of active transducer, whereas potentiometer, it is an example of passive transducer. Next classification of transducer is analog and digital transducers. So analog transducers are those transducers which convert the input quantity into an analog output. Analog output means the analog signal. Analog signal is a continuous function of time. If we see the graph for an analog signal, the analog signal will be like this, which is changing continuously with the time. Okay, whereas the digital transducer, they convert the input quantity into a digital output, which is in the form of pulses. Okay, so digital transducer, they are going to give the digital output, which is in the form of zeros and ones. Okay, so zero will be there or either one pulse will be there. Okay, so in this form we will get a digital output. Now the digital output, for the analog transducers, we can use the analog scale, which is having the scale divisions over it. Okay, an example of analog transducers are the LVDT, strain gauge, thermistor, thermocouple. All are the examples of analog transducers which are giving us the analog output. Like in the strain gauge, we are getting the change in the resistance. In the thermocouple, in LVDT, we are getting an output voltage which is also changing with time. So we are getting an output which is changing or continuously changing with the time. Okay, and that output can be read from an analog scale. Whereas for the digital output, we are having the zeros and ones value. So for them, we can use either the glass scale or the metal scale. So we are having two values, 0 and 1. So in the glass scale, 0 is represented by the opaque and the transparent areas. Zeros and ones can be represented in this form, and in the metal scale it can be conducting and non-conducting areas. So on the glass scale, we are having the opaque and the transparent areas, and they can be read with the help of the optical systems or the photocells. And the conducting and non-conducting areas, they can be used with the help of the brushes, which can keep a track over these conducting and non-conducting areas. With the help of that, we can read the value that whether it is 0 or it is 1. When it is conducting, it means 1. When it is non-conducting, it means 0. When it's opaque, it means 0, and when it's transparent, it means it's 1. Okay, so in this way, for the digital output, we are having the glass scale and the metal scale, and for the analog output, we are having the analog scale. Okay, so this was the classification of the transducers as analog and digital transducers, depending upon that depending upon the nature of the output signal, that whether it is an analog signal or an digital signal. Next classification of the transducers is transducer and inverse transducers. Now we know that a transducer, it is a device which converts a non-electrical quantity into an electrical quantity. Whereas inverse transducers are those devices which do the reverse of it. Okay. Example of transducer is the LVDT. Okay, in the LVDT, that is linear variable differential transformer, the displacement, which is a non-electrical quantity, it is converted into voltage, which is a electrical quantity. Okay, so example of transducer is LVDT, thermocouple, thermistor, and in the RTDs, in strain gauge, all these are the transducers. Now if we talk about inverse transducer, they convert an electrical quantity into a non-electrical quantity. Example of inverse transducer is a current carrying coil in a magnetic field. This is an example of inverse transducer because the coil which is carrying the current and it is placed in a magnetic field, it is going to produce a force. So here current, which is an electrical quantity, it is converted into a non-electrical quantity, that is the force. So current carrying coil in a magnetic field, it converts the current into the force, and this force causes either the translational or the rotational displacement. So this is also an example of the inverse transducer. Another example is the piezoelectric crystal. Piezoelectric crystal is a transducer also and is an inverse transducer also. Transducer because it converts the acceleration into the output voltage, and also inverse transducer because it can convert the voltage or into the acceleration also. Okay, so piezoelectric crystal is an example, or we can say that it's a unique example which is acting as a transducer also and as an inverse transducer also. Also, if we talk about the analog ammeters and the voltmeter, which are measuring the current and the voltage, and they are showing the value of that current and voltage over the calibrated scale. So you can, if I draw here the diagram for an analog ammeter, so when this ammeter is connected in the circuit, it is going to measure the current, and due to that current, the displacement of the pointer over the calibrated scale is caused. So here also an electrical quantity is converted into a non-electrical quantity. So these all are example of the inverse transducers. So in this video, we studied about the classification of transducer. We saw that what are the various criteria on the basis of which the transducers can be classified. After that, we see the classification of transducers on the basis of the principle of transduction, primary and secondary transducers, active and passive transducers, analog and digital transducers, and inverse and transducers and inverse transducers. So I hope that this topic, classification of transducer, it is now clear to you. Thank you.